Amid the sprawling immensity of our galaxy, home to countless icy gas giants, lifeless rocky spheres, and vast stretches of silence, there is one extraordinary planet that stands out from the rest, K2-18b, orbiting a cool red dwarf star more than 110 light-years away in the constellation of Leo. This distant world may be the closest analog to Earth ever discovered, and possibly our first real lead in the search for extraterrestrial life. For years, astronomers observed oddities in its atmosphere, initially detecting water vapor, then signs of carbon-based molecules. But now, thanks to the James Webb Space Telescope's unprecedented atmospheric analysis, something even more profound has come to light, data that can no longer be explained by chemistry alone. What Webb has detected may be the strongest evidence yet of biological activity on an exoplanet, gases that, on Earth, are produced exclusively by living organisms. This is no longer speculation. It's scientific observation. And with it comes the unsettling realization: perhaps we were never truly alone. K2-18b belongs to a class of exoplanets known as Haitian worlds, a fusion of hydrogen-rich atmospheres and vast global oceans. It is significantly larger than Earth, with a radius 2.6 times greater and a mass 8.6 times more massive. What makes this planet particularly compelling is its location in the habitable zone of its star, the region where temperatures may permit liquid water to exist. Unlike Mars, which is dry and desolate, or Jupiter, which is too hot and gaseous, K2-18b may be enveloped in a thick hydrogen atmosphere that shields it from cosmic radiation while maintaining relatively temperate conditions. Analysis from Webb has confirmed the presence of water vapor, methane, and carbon dioxide, essential ingredients for life. When these compounds are found together in a hydrogen-rich environment, they create a profile that strongly suggests the presence of biological activity below the ocean surface. But the most startling discovery came in 2025, when Webb's mid-infrared instrument, MIRI, detected a compound rarely found in nature without biological origins: dimethyl sulfide, DMS. On Earth, DMS is almost entirely produced by living organisms, particularly microscopic marine phytoplankton. Finding this molecule on another planet is comparable to discovering oxygen on Mars. It hints not just at chemistry, but at biology. Even more intriguing was the detection of dimethyl disulfide, DMDS, another compound linked to microbial activity in Earth's oceans. The presence of both these molecules, alongside water vapor and organic gases, has led scientists such as Cambridge astrophysicist Dr. Niku Madhusudan to theorize that K2-18b may be teeming with alien microbial life. These aren't unverified headlines. They're peer-reviewed molecular signatures, statistically consistent and verified by robust data sets. The scientific community is beginning to view K2-18b as potentially the first confirmed alien biosphere, one in which the oceans may not just exist, but live. What kind of life might thrive beneath those alien seas? If DMS is indeed a biological byproduct, the likeliest explanation is that K2-18b's oceans harbor organisms resembling Earth's phytoplankton, microscopic life forms capable of photosynthesis, using the dim red light from their dwarf sun. Some theorists, however, suggest more elaborate ecosystems. These might include filter-feeding organisms similar to Earth's first multicellular life, drifting through nutrient-rich waters and leaving detectable chemical trails. Others imagine strange, buoyant life forms adapted to K2-18b's low gravity and high-pressure environment, perhaps even creatures capable of gliding briefly into the hydrogen atmosphere. In this way, K2-18b might resemble Earth as it was over 3 billion years ago, at the dawn of life. Just as Earth's early biosphere gradually transformed its own atmosphere, so too might we be witnessing the same transformation unfolding now, in real time, on a world light years away. With each new discovery, humanity faces profound questions. Should we attempt to contact whatever life may exist there? Some scientists argue firmly against it. Physicist Mark Buchanan cautions that transmitting messages to unknown ecosystems could expose us to civilizations we aren't prepared to engage with, or worse, could disturb fragile alien environments. Ethicist Dr. Anthony Milligan emphasizes our moral responsibility not only to safeguard Earth, but to avoid interfering with any native life we might find. Others, like Avi Loeb, contend that any intelligent species capable of detecting our signals would likely have done so already and might not even consider us relevant. In any case, a radio signal from Earth would take 120 years to reach K2-18B, and just as long to receive a reply. For now, humanity waits. But the evidence grows stronger. The molecules are there. The ocean is likely real, and the idea that Earth is alone in the cosmos is losing credibility. As K2-18B captures the attention of the scientific world, space agencies and private aerospace firms are already re-evaluating their goals. While our current propulsion technologies would take centuries to reach this distant ocean world, the next phase of exploration is already being mapped. NASA is accelerating the development of advanced observatories like LUVOIR and HABEX, designed specifically to study exoplanet atmospheres for signs of life. The European Space Agency and China's CNSA are developing their own deep space monitoring platforms. Meanwhile, the idea of launching interstellar probes is gaining traction. The Breakthrough Starshot initiative, backed by scientists and billionaires alike, proposes sending gram-sized probes using laser propulsion at speeds approaching 20% of light. If successful, these probes could reach K2-18B in about 500 years, a long journey by human standards, but fleeting in cosmic terms. Even if we never set foot there, we may still bear witness to the moment Earth reaches out to life beyond itself. The implications of this discovery go far beyond science. Around the world, religious leaders, philosophers, and spiritual thinkers are grappling with what it means. Some see it as confirmation that life is not exclusive to Earth, but a widespread phenomenon embedded in the universe's design, a cosmos oriented toward awareness, not emptiness. Others respond with unease or outright denial, arguing that society may not be emotionally or philosophically ready to face the truth. Social media has exploded with interest. Hashtags like K2Alive and Ocean World trend globally, while filmmakers rush to produce documentaries and speculative dramas. Governments remain cautiously optimistic, balancing enthusiasm with careful, scientific analysis. But beneath the public discourse, something deeper is shifting. The realization that we are not merely observers of the universe. We are perhaps finally being observed in return. And for the first time in recent memory, the human race is experiencing a rare kind of unity. Not in fear, but in wonder. As our fascination with K2-18B intensifies, so does the conversation around how we engage with it. Scientists and ethicists alike are urging a framework of planetary protection, not for Earth, but for the biospheres we may discover. International groups are already proposing a new classification for such planets, exobiological sanctuaries. These would be celestial bodies where signs of life have been detected and which must be observed remotely to prevent contamination. Astrobiologist Dr. Monica Vidari stresses that if life on K2-18B truly exists, it has evolved independently over billions of years, and we have no right to disrupt it. Some proposals go as far as suggesting a form of interstellar no-fly zone, placing restrictions on future probe emissions or trajectories. The underlying message is clear. Just because we can explore doesn't mean we should intrude. Even if the planet's oceans appear silent, even if the life there is microbial, it would still be the first known kin we've ever found in the universe. And wisdom calls us to listen before we act.